Dear student, today I want to discuss about carbon and its compound topic. This topic is very important in the chemistry because carbon is a special element in the periodic table. So how it is special? Which properties are shown by this carbon atom? That we have to study in this topic. Before that, I want to clear some basic regarding this carbon. We know student, the symbol of the carbon is C. Its atomic number is 6. It contains 6 protons and 6 electrons. If we see the atomic structure of the carbon, there are two shells are there. This is the central part of the carbon, which is called as a nucleus. And these are the two shells. The first cell contains the 2 electrons and the second cell contains the 4 electrons. First cell having the 2 electrons, second cell having the 4 electrons. So if we see the electronic configuration of the carbon atom, how we can write the electronic configuration of the carbon atom? That is 1s2, 2s2, 2p2. So first of all, I will clear what is meant by the electronic configuration. The simple meaning of the electronic configuration is nothing but the distribution of electrons into the different shells according to the energy level. See children, we cannot keep all the electrons in the particular shell. That is not possible. Whenever we want to keep the electrons into the different shells, we have to keep the electrons according to their capacity. So, when we are keeping the electrons according to their capacity into the different shells, that is nothing but the electronic configuration. So electronic configuration is nothing but distribution of electrons into the different shells according to the energy level, that is called as electronic configuration. Now you see, what is the electronic configuration of the carbon atom? That is 1s2, 2s2, 2p2. Here you see two shells are there. Last cell contains the 4 electrons. So it is called as a tetravalent. It is called as a tetravalent in the nature. Tetra in the sense 4. Why the name is given as a tetra? Because in this carbon, last cell contains the 4 electrons. So it is called as a tetravalent in the nature. And because of this tetravalent nature, carbon can make the 4 bonds with other carbon atom or with other different atom. For example, you see, this is the carbon. Okay, so it having the valency that is 4. So he can make the bond with other carbon atom or he can make the bond with other atom apart from the carbon. So tetravalency. So what is meant by the valency? And how we have to find out the valency? Valency is nothing but the combining capacity of that element. So here carbon combining capacity is 4. That's why it is called as a tetravalent in the nature. And because of this property, it is called as a versatile in the nature. So what are the other properties? So carbon, it is called as a versatile in the nature, that I am going to discuss right now. First we discuss about that is tetravalent in the nature. Second property that is isomerism. What is meant by the isomerism? So as we discussed, that is carbon is a very popular, or carbon it is called as a versatile in the nature due to the property of tetravalency. This is the second property, that is isomerism. So what is meant by the isomerism? First of all, I will write the definition of isomerism here. The compound which having same molecular formula same molecular formula, but different structural formula, So how you can define the isomerism? The compound which having the same molecular formula but different structural formula, this is called as isomers of each others, and this concept is known as isomerism. Let's take one example to understand this concept in the clear way, how the isomers of each others. I will take some example to understand this concept in the better way. For example, you see, I will take here one simplest hydrocarbon, that is normal butane, CS3, CH2, CH2, CS3. Now you see here, total 4 carbon atoms are there in this compound. And hydrogens, this 3 plus 2, that is 5, and this 3 plus 2, that is 5. So total 10 hydrogens are there. So I will write here the molecular formula, that is C4H10. Okay. The name of this compound, that is N-butane. Now you see, what I will do here, I will keep the same molecular formula, but this N-butane I will arrange in the different way. So how I will arrange? For example, you see CS3, CH, CS3. So this is called as isobutane. Now you see, children, here also 4 carbon atoms are there. 1, 2, 3, 4 carbon atoms are there, and total number of hydrogens are 10. 3 plus 3, that is 6, and this 3 plus 9, and this one more hydrogen, that is a 10. So here also 10 hydrogens are there. Now you see, both this compound, okay, they having the same molecular formula, but the structural formula is different. So they are called as isomers of each others. And this phenomenon is known as isomerism. And that is the reason only this carbon is considered as a versatile in the nature. Now we discuss about the isomerism and tetravalency. One more property that I am going to discuss about this carbon topic. That is nothing but the catenation. So third property, that is catenation. So what is mean by the catenation? Catenation is nothing but it is a self-linking capacity. It is the self-linking capacity of carbon atom. Now you see what happened here. For example, you see one carbon is linked with another carbon. The second carbon is linked with third carbon. Third carbon is linked with fourth carbon. So in this way, what happened? One carbon is connected with another carbon. Another carbon is connected with the third carbon, and third carbon is connected with the fourth carbon. So this is called as a catenation. So in this catenation, what happened exactly? It is the capacity of carbon atom where there is a self linkage takes place. So that is called as a catenation. So as I told you, that is tetravalency, isomerism, catenation. Now you see, okay, because of this catenation, there is formation of long chain or there is formation of straight chain. Okay, remember that is. There is formation of a branched chain also. For example, you see, there is formation of branched chain also. Now you can see this structure. Okay, there is a branched chain is there. Even carbon have the ability to make the cyclic compound. For example, you see, even carbon have the ability to make the cyclic compound. Okay, now you see, because of this catenation, carbon having the ability to make the long chain, carbon having the ability to make the branched compounds, carbon having the ability to make the cyclic compound, that is. And because of this reason, this carbon is known as versatile in the nature. This, because of these three properties, this carbon is known as a versatile in the nature. Even we know that if we discuss about the classification of this carbon, okay, classification of this carbon, especially it is called as hydrocarbons. It is called as hydrocarbons. Hydrocarbon means what? Hydrocarbon means what? Majority, the compound which contain hydrogen and carbon, that is called as hydrocarbon. Okay, if we think about the organic chemistry, okay, when we are talking about the organic chemistry is nothing but it is the branch of chemistry which deals with the study of carbon and hydrogen, and those compound is called as a hydrocarbon. Now, the simple meaning is that hydrocarbon is nothing but the compound which contain hydrogen and carbon, that is called as a hydrocarbon. Now you see children, if we see the classification of this hydrocarbon, how this hydrocarbon they classify? This hydrocarbon they classify into the three different groups, okay? Remember, that is one that is called as alkane, another that is the alkene, third one that is the alkyne, Here what happened, you see, in case of alkane, there is a carbon-carbon single bond is there. In case of alkene, there is a carbon-carbon double bond is there. In case of alkyne, there is a carbon-carbon triple bond is there. Means, what is the nature of the bonding in between the two carbon atom? If the carbon-carbon having the single bond, then it is called as alkane. If the carbon-carbon having the double bond, then it is called as alkene. And if the carbon-carbon triple bond is there, then it is called as alkyne. Especially if carbon-carbon single bond is there, then such a compound is called as a saturated compound. It is also called as a saturated hydrocarbon. Suppose carbon double bond carbon triple bond carbon, so it is called as unsaturated hydrocarbon. Keep in the mind, it is called as a unsaturated hydrocarbon. Now you see, saturated hydrocarbons are less reactive and unsaturated hydrocarbons are more reactive. Saturated hydrocarbon, they undergoes the substitution reaction, and unsaturated hydrocarbon, they undergoes the addition reaction. Okay, remember that is saturated hydrocarbon undergoes the substitution reaction, and unsaturated hydrocarbon, they undergoes the addition reaction. Now, what is the general formula for the alkane? For example, you see CnH2n plus 2. This is the general formula for the alkane. CnH2n plus 2. Here n is nothing but the number of carbon atoms. By using this formula, if we know the value of n, we can find out the value of H. Okay, remember that is, if we know the value of n, we can find out the number of hydrogens present in the particular compounds. Now, the general formula for the alkene is CnH2n, and the general formula for the alkyne is CnH2n minus 2. Okay, so what is the general formula for the alkene? That is CnH2n. The general formula for the alkyne, that is CnH2n minus 2. It's clear. Again here same, that is n is nothing but the number of carbon atoms. Okay, if we know the carbon atom, we can find out the number of hydrogen atom. Here also same, that is n is nothing but the number of carbon atom. If we know the number of carbon atom, by using this formula, how much hydrogens are present in the alkyne, that we can find out. So this is the general formula for the alkane and alkyne. Now, how this alkane and alkene, they undergoes the different reactions, that I want to discuss. So as I told you, that is alkane undergoes the substitution reaction. We will take one example and we will come to know that is how alkane undergoes the substitution reaction. For example, you see, I will take the simplest hydrocarbon, that is the methane. I will take the simple hydrocarbon, that is the methane. This methane, it will react with the chlorine, that is Cl2. So what happened here? We are getting that is CH3Cl plus HCl we are getting. CH3Cl plus HCl we are getting. So it is called as a methyl chloride. 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 Here what happened you see? Okay, one of the hydrogen from the methane is replaced by the chlorine. So we are getting that is a methyl chloride. We are getting that is a methyl chloride plus HCl we are getting. Now only one more reaction we will discuss, that is addition reaction, that is addition reaction. So as I told you, that is this methane, that is the simplest hydrocarbon which undergoes the substitution reaction. Okay, so we will take one simple alkene, that is R, C, R, double bond C, R, R. So this is the alkene which is called as an unsaturated hydrocarbon. It undergoes the addition reaction in presence of catalyst nickel and palladium. So here what happened, across the double bond there is addition of hydrogen takes place. Okay, so what we are getting, R, C, R, H, double bond is converted into the single bond, R, R and H. Now you see, this is the alkene which is called as unsaturated hydrocarbon, and this is the alkane which is called as a saturated hydrocarbon. So here what we got, here we got saturated hydrocarbon from the unsaturated hydrocarbon, and this reaction is known as addition reaction.